So electron orbit. So here, so this is the nucleus, and think that this is the electron. Electron is revolving around the nucleus. So what there are two forces. There are two forces here. One is this is proton neutron, and this is Z. Z is the, suppose if you are taking a hydrogen atom. Okay, if you are taking hydrogen atom, there will be only one electron. This is said to be one electron model. Okay, hydrogen atom is also known as one electron model. Okay, clear? Okay, so here this is the hydrogen atom. So what is there are two forces which are balanced. That is what Fe is equal to Fc. That is electrostatic. Coulombic. There are two forces. One is Coulombic force. One is electrostatic force. Coulombic force means what? Now, when an electron is moving around the nucleus, so now what is the formula here? Mv square by R is equal to 1 by 4 pi epsilon 0 into E square by R square. Is that clear? So here, what happens now? Mv square by R, this R and this R will go away. Okay, these two R's will go away. So cross multiply this now. R is equal to how much? R is equal to E square by 4 pi epsilon 0 mv square. Is that clear? Now, so radius is given to us. Now the kinetic energy formula is what now here? Kinetic energy formula is half mv square. Half mv square, which is equal to what? So here it is. So this kinetic energy formula came from the derivation. Actually, this derivation should have been after the three derivations. But anyways, I'm going to substitute the velocity equation here. So I'll write the velocity expression here. So the velocity expression is given by, here I write it here. So the velocity expression is given by, E is equal E by under root of 4 pi epsilon 0 into m into r. Okay, 4 pi epsilon 0 m into r. So therefore, k is equal to half mv square, E by under root of 4 pi epsilon 0 into m into r whole square. So k is equal to half m into E square divided by 4 pi epsilon 0 into m into r. Okay. Now, this m and this m will go away. So k is equal to what? E square by 8 pi epsilon 0 into r. Okay. Okay. Now, so this is the formula. Okay. Energy formula. Now, so we got 8. This is the kinetic energy formula. But potential energy formula is what? Minus E square by 4 pi epsilon 0 into r. From where we got this one? We got from second chapter. Okay. So this one we got from the second chapter. Second chapter, what is the formula? The energy formula. U is equal to what? 1 by 4 pi epsilon 0 into Q1 Q2 by R. You remember this? Second chapter. Potential energy formula.
Yes, sir.
So the potential energy formula is 1 by 4 pi epsilon 0. Q1 Q2 by R. So it is because electron is one is positive, the other because it's attractive force. Also, the second one is what? Electron is negative and negative charge and proton is positive, so plus into minus will become minus. Okay, so U is equal to, you got two energies now. We'll add both the energies. So what are the energies? The total energy is equal to kinetic energy plus potential energy. Kinetic energy is how much now? Kinetic energy is E square by, so E square by 8 pi epsilon 0 into R minus E square by 4 pi epsilon 0 into R. E is equal to E square by 4 pi epsilon 0 into R, 1 by 2 minus 1. So E is equal to E square by 8 pi epsilon 0 R. This is the total energy. Is that clear now? Is that clear?
Yes, sir.
Yeah, minus 1, this will become minus, okay? See, once again from the beginning, so this is a hydrogen atom. We are trying to find out the energy of the orbit. So this is a one electron model. Hydrogen atom is also known as one electron model. Electron is revolving around the nucleus. So here we have Fc is equal to Fe. The centripetal force is what? Mv square by R is equal to 1 by 4 pi epsilon 0 E square by R square. Cross multiply it. Then we get this formula. What is that? Kinetic energy is equal to half mv square. We have V value here. Just square it. Then we'll get this value. This is the kinetic energy value. And potential energy is what? This we got this formula from here. From the second chapter, potential energy. Okay. Now you have kinetic and potential. So we are adding both of them to get the final answer. Clear? Is that clear?
Yes, sir.
Okay, please note down this.